In this video, we are going to discuss problem based on a charge particle that enters at an angle to the magnetic field. So let's say you have a charge particle whose velocity vector makes an angle theta with the magnetic field. How do we describe motion of this charge particle inside the field? Now, if the velocity is making an angle theta, we can split this velocity vector into two components. One component which is moving parallel to the field, which we'll call as V parallel, and the other component which moves perpendicular to the field, which we call as V perpendicular. V perpendicular can be calculated by using the rule V sine theta, and V parallel can be calculated by using the rule V cosine theta. And these two velocity vectors will have their own effect on the trajectory of the charge particle, and the resultant effect will be a superposition of these two. So whenever a charge particle enters perpendicular to the magnetic field, we know it goes around a circular path. So because of the perpendicular component of velocity, the charge particle will move around a circular path like this. But since we also have a parallel component, if any charge particle moves in a magnetic field parallel to it, there is no force acting on it, and the particle continues to move along the same path undeviated. So the parallel component of charge particle will allow the charge particle to move forward undeviated. So now we have two parts here. One component which is causing the particle to move along a circular path, another component which is allowing the particle to move forward. And when you combine these two motion, you get a motion which forms a helical path. So the charge particle will move along the magnetic field in a helical path like this. And we need to find the radius of this helical path in this particular problem. So here in this question, you have an electron which is moving with a speed of 4 times 10 to the power 5 meter per second, and it enters a uniform magnetic field of magnitude 0.04 Tesla at an angle of 35 degree to the magnetic field line. And they said that the electron will follow helical path. We need to determine the radius of the helical path. So let's discuss the part A first. When you're determining the radius of the helical path, we need to first understand which component of velocity is responsible for circular motion. We already discussed that it is the perpendicular component. So when we are finding the radius of helical path, we will focus on this velocity. If the charge particle must move along a circle, there must be a centripetal force enabling that motion. And in our situation, that centripetal force is given by the magnetic force. Centripetal force can be written as mv squared over r, and magnetic force will be qvb. And since this motion is described by the perpendicular component of velocity, this value of v will be v perpendicular. Next, we can cancel the v over here and one v from here, and we are left with mv perpendicular over r equals qb. Then we can rearrange to write r to be equal to mv perpendicular over qb. So v perpendicular is nothing but v sine theta. So we get this as mv sine theta over qb. Now let's substitute to get the value for r. R will be equal to mass of electron is a constant, which is 9.11 times 10 to the power negative 31 kilogram. So we write the mass as 9.11 times 10 to the power negative 31. Speed v is 4 times 10 to the power 5. Angle theta is 35. Charge of electron, we will only take the magnitude of the charge, which is 1.602 times 10 to the power negative 19. The magnetic field B is 0.04 Tesla. And when you solve this, you get the radius of the helical path to be equal to 3.26 times 10 to the power negative 5 meter. Next in part B, they're asking us how far forward will the electron have moved after completing one circle. When they are asking you how far forward, that means they are asking you the distance d the electron covers when it is completing one circle. We can calculate the distance d by multiplying speed with time. And here the component of velocity responsible for taking the electron forward is v parallel. So I will multiply v parallel with time t. I know v parallel is v cosine theta. I need to find what is the time t. So let me call this as equation 1 and go along to find what is the time t. We need to find the time it takes to complete one circle. Now when you move along one complete circle, the distance you travel is 2 pi r. So if I want to find the time t, we know we can find time t to be equal to the distance covered over the speed with which you are moving. So distance covered while going around a circle is 2 pi r, and the speed responsible for taking the electron along a circular orbit is v perpendicular. So we write the speed as v perpendicular. Radius of the circular path we can substitute from the expression over here that we calculated before. I will substitute r as this. So we get t to be equal to 2 pi over v perpendicular, and r we can write as mv perpendicular over qb. Now cancel off v perpendicular from here. We get the time to be equal to 2 pi m over qb. Now let's substitute this value of time in equation 1 here. So we can rewrite t to be equal to v parallel times t, which will be v parallel we can write as v cosine theta, time t we can write as 2 pi m over qb. Now let's substitute to find d. D will be equal to velocity v is 4 times 10 to the power 5 into cosine of the angle 35 into 2 pi into mass of electron, which is 9.11 times 10 to the power negative 31 over charge of electron is 1.602 times 10 to the power negative 19, and magnetic field B is 0.04 Tesla. And when you solve this, you get the value of D to be equal to 2.926 times 10 to the power negative 4 meter. So this is how far along the electron will move when it completes one circle. So anytime a charged particle enters a magnetic field at an angle, it follows a helical path inside the magnetic field. And velocity component can be divided into two parts. One part which is perpendicular, that is responsible for the circular motion, and one part which is parallel, that is responsible for the forward motion. So any quantity related to circular path like the radius of the orbit, you have to use v perpendicular. And if you want to find how far the particle went, you will have to use v parallel.